Okay, here we go. So base is other than e. We know how to integrate. The only base we know how to integrate is e to the u du. What's the integral of e to the u du? What's that integral, e to the u? E to the u plus c. We know how to do that. We don't know how to do a base that is not e. So we need to turn this a to the x into base e, into this integral. So what we're going to do is we're going to rewrite it as this. E to the natural log ax. Can we agree that that is the same thing? And why is it the same thing, I guess, is the real key here. Yeah, so if you remember your log rules, if you have base b to log base b of x, as long as this and this are the same, it just equals the argument, okay? And natural log is what base? It's base e. So we haven't changed anything by writing it as e to the power of natural log of x. Because we are logging this, we can now bring down this x here and get the integral e to the x natural log of a. I guess I should have a dx here. All right. Then what we're going to do is we're going to do a u substitution. What do you think u should be? X ln of a. So we're going to go u is equal to x ln of a. So du is equal to what? Ln of a, because ln of a is a constant, right? So we just derive the x and it has a derivative of 1. So the derivative is just ln of a times dx. I'm going to divide off the ln of a. And that's going to give me that, which I can then sub back into this. So this is u, and dx we've said is du over that. So we get the integral e to the u du over natural log of a. The ln of a is a constant, so I can pull it outside of the integral. So I'm left with the integral 1 over natural log of a, integral eu to the d of du. What's the integral of e to the power of u? EU plus c. And then the constant's in front. So it's 1 over ln of a e to the u. Put back in our u, which was x ln of a. To the x ln of a. I'm going to move this back up there. There's a plus c there. So you get 1 over ln of a e to the ln of a x plus c. Is everybody with me?
Oh, we just put the exponent back up on there?
Yeah, I just put the x back up to the exponent. What is e to the natural log of anything? It's a to the x, right? Whatever that is.
Oh, the argument.
Yeah, the argument. So then this bit just becomes a to the x. So you end up with 1 over the natural log of a to the x plus c. So that's a long-winded way of developing. That's the formula. So essentially what we just showed is that the integral of a to the x dx is equal to 1 over the natural log of a times a to the x plus c. Yes. This bit. This is essentially the same that we did here. From here to here is the same thing because that's log base. Log base is half. So it equals that. Okay. All right. So if you're just doing a few of these, sometimes the formula is better, or you can develop it if you want every single time. I think I'm just going to stick with the formula. Okay. You will get a formula sheet. So if we'll start with a simple example. If we have 2 to the power of x dx, we can just use the formula. What's my base? 2. So it's 1 over the natural log of the base. It's a nice purple shade. There we go. 1 over the natural log of the base times what it is, 2 to the x, plus c. You're done.
How do you know 2 to 3?
All right. What if it doesn't look exactly like the formula? So what if we have 3 minus x, 7 to the power of 3 minus x all squared dx?
Wait, 7.
Sorry?
I'm just 7 being raised to.
Yeah. So in these cases, because it doesn't look like our formula is a to the x, okay, or a to the u if you want. So what we need to do if it looks like this, you have to use u substitution. Okay. So we go, all right, u is equal to, what's u equal to? 3 minus x squared, because your whole goal is to make it look like this. Okay. So I'm going to say u is equal to 3 minus x all squared. So du is equal to, what's du equal to? Negative 2? Oh, I see. Yeah, okay. So 2, drop the 2 down. 3 minus x to the power of 1 times the inside derivative, which is negative 1. And then there's a dx there. So I'm going to divide off negative 2. Does everybody agree with that? Because then I'll have 3x dx, which is right there. So if I go du over negative 2, that leaves me with 3 minus x dx. So then, if I sub back into here, I get the integral 7 to the u du over negative 2. Everybody with me on this? Okay, now this looks like our formula, a to the x dx, right? So we just go, okay, it's 1 over natural log of the base, which is 7, times what that was, 7 to the u. But remember, there's a negative 1/2 sitting out front, right? So I'll put give myself some more room here. Negative 1/2 natural log of 7, 7 to the u. So I'm going to rewrite it as negative 1 over 2 natural log of 7, 7 to the u. What's our u? 3 minus x all squared. Tack on a plus c, and you are done.
Can you explain this after you put like 7
I just integrated it using this formula. Because now it matches this formula. All right, so then it's 1 over the natural log of the base times that base exponent. That's this bit. and the negative 1/2, because essentially I pulled out a negative 1/2, and I'm doing that. Is that okay? All right. Well, let's do. Integral 3.
Oh.
Right. I think I did happy. No, what did I do yesterday for you? But you weren't
You're
here.
like smiley face.
Yeah.
And like a Z
Yeah.
numbers.
I could do 4 minus 1. There we go. Is that better? All right. 3 to the power of 2x over 1 plus 3 to the 2x dx. So what do we do here? You could split it apart. I don't know if it's going to help you, though. And it'd be tricky to split it apart. So what are we going to do? U sub? Is that what somebody said?
Yeah.
Okay, what's U?
the denominator.
Yeah, it's the denominator. If you make U equal to 3 plus 3 to the 2x, you'll end up with this integral, which doesn't totally help you. Okay? So we're going to do U is equal to the denominator, 1 plus 3 to the 2x. All right, so what do? We have to derive it, right?
I've got to try this.
So this is what we did yesterday. So in the middle of this, you're using the logarithmic integration that we did yesterday, right? Of bases underneath. So if we're going to do this, we're going to go du dx. I'm going to do it properly. Okay? What's the derivative of 1? 0. That's easy. It's this thing here that is tricky, right? So what you're going to do is you're going to go off to the side and you're going to go, okay, we're going to make y equal 3 to the 2x. We're doing a little side derivative here. Side derivative. So we say, okay, y is equal to 3 to the 2x. We need to take the derivative of this. So what do? We log it because we got some weird exponential function. So we natural log both sides. And we get the 2x to fall down. What's the derivative of the natural log of y? What's the derivative of 2x natural log of 3? 2 natural log of 3, because really this is all being multiplied, and the 2 and the natural log of 3 are all constants. So it's just 2 natural log of 3. Then what do? Multiply the y up, and what is y? It's 3 to the power of 2x, so we got y primed is equal to 3 to the power of 2x. 2 natural log of 3. If you want to clean that up, what can I do with the 2 there? Yeah. I could move this 2 up to there and get natural log of 9 just to clean it up a little bit. Okay? That is the derivative of 3 to the 2x. You good? So that is what goes up here. 3 to the 2x natural log of 9. So that goes right there. Okay. I multiply the dx up and I divide off the natural log of 9. Are we with me? So this is the derivative. I'm dividing off the natural log of 9 and multiplying the dx up. Okay, now 3 to the power of 2x dx is right here in our integral. We've already said that that is u. So this integral becomes the integral of 1 over u du over the natural log of 9. Which you can pull out the 1 over natural log of 9. Do the integral of 1 over u du. What's the integral of 1 over u du? What's the integral of 1 over u?
Natural log of u.
Yes, it's the natural log of u. Right? Remember that from a couple days ago? This like has everything we've pretty much done this week in one question. Is that awesome? All right, are we
Yeah, I'm kind of lost after the
I don't really know.
okay? Where did you get lost?
Absolutely.
when we drive like 3 years.
Just in the beginning.
No, maybe on the second. It goes.
Does everybody understand how I got the derivative here?
No.
That was a lot of mumbling. So, okay, let's go back up. Let's watch this through. Okay, we don't know what to do. So we make u our denominator. Everybody's on board with that, right?
Yeah.
Okay, so this is our denominator. I take the derivative. These are being added, so I can do each one separately. The derivative of 1 is 0, so that's just gone. Then I gotta do the derivative of this. So unless you've memorized the formula, you have to go off to the side and say, okay, I'm pretending that I have a function y is equal to 3 to the 2x. I want to take the derivative of it, but I don't know how to do that, so I'm going to log both sides, which allows this exponent to come down. Yeah? Okay, then I derive it. Y prime over y, dx just goes away, I get 2 natural log of 3. I multiply up the y, which is this. This is my derivative. I just moved the 2 up to make it 9, to make it a little cleaner. So this is the derivative of this. So I put that back here, and I go, okay, I need to get rid of this 3 2x dx. So I multiply the dx up and divide off the natural log of 9.
The thing that I don't understand, why did you keep like 3 to 2x? I thought we were supposed to derive it. Like,
We did. We did it right here. But when you multiply the y up,
oh, okay.
that's where that comes, it's still there.
Okay.
So now we've got this. I sub it into here. The integral turns into this. 1 over u du over natural log of 9.
Okay.
So what about the absolute value?
We'll do that at the end. We're almost there. So then I can pull out the 1 over natural log of 9, 1 over u. Now, this is the natural log integral, right? Because the derivative of the natural log of u is 1 over u, right? Times u prime, essentially, but that's the u. Okay? You have to absolute value it because you cannot log a negative number. Yes?
Sure.
Well, if you remember the graph, unless you shift it, but we don't have a shift here. This is a log graph, right? You can't, like it has an asymptote at 0, and there's nothing over here. Okay, so you can't log a negative number, so that's why they put an absolute value. Okay?
In most situations, we use the absolute value.
Well, we'll look at it in a sec here when I sub back in. Okay? Are we good with that? Okay. But now we got to put back in what u was. What the hell was u? 1 plus 3 to the 2x. So this becomes 1 over natural log of 9, natural log of 1 plus 3 to the 2x. Okay, plus c. Now we ask ourselves, look, in my class, I don't care if you leave the absolute value there. If you're a Math 100, we have a guest today. All right. She cares. So my question is, do you need the absolute value?
Yes.
Who said no?
No, there's no. It's positive.
It's always going to be positive. You don't need it. If you put 0 there, what do you get? What does this become? 1. If you put a negative number there, what does this become? So like a fraction, right?
Yeah.
So then it's 1 plus a fraction, still positive. It's a positive number, and some positive number. It's because you're always adding, right? Because of this. If that was a minus, then you'd have to keep the absolute value. All right? Okay, so we can erase the absolute value. I'm just gonna literally erase it and put brackets around it. That is your answer. Wasn't that fun? That was pretty much everything from the week baked into one question. I have not made the test yet. Page 363, 71 to 83 odd. Just make everything match the formula we designed at the beginning, which is this formula. So you're doing U subs to get there. All right, there's your questions. You've got 20 minutes. Go.